Hello everybody and welcome back to the Code Wrinkles channel for a brand new video. In this one we will try to build actually our own IoC container, and this video is meant to be a sequel to the video on the dependency inversion principle that we have covered within the Solid series, and we have for that a playlist. So if you didn't watch that video, it would be highly recommended if you want to really understand the entire setup and what we are actually trying to achieve here. It's very well, it would be useful that you could also go and watch this video. You can find the link here somewhere up right in the corner, and that should do it for you. But if you're familiar with the dependency inversion principle, then this is no problem. You can surely watch the video because we'll do also a short recap, very short recap, and then we would be good to go. Now, there is one other thing that I want to say just before we get started is that what we do in this video, we don't aim to actually rebuild the kind of like setup or the dependency injection container that we have in .NET Core. No, that's not something that we need to do, or that's not something that we will do here in this video, because what I would like to cover here is also a conceptual continuation of the dependency inversion principle, and I would like to actually go deeper into one principle that I have explained there and that I will actually re-explain here, that the interfaces should always be owned and defined by the client. And the reason why we create a dependency injection container is actually that we will see that if we stick to this principle, we might have actually some problems when we want to build an IoC container. And for this purpose, what we'll try to do is actually to simulate an IoC container based on a very simple factory that would kind of like return us a logger, and that would be it. Cool. So let's get started. So we have here the solution. It's exactly the solution that we had previously in that other video on the dependency inversion principle. There are only some slight changes that I have done here, because in that video we haven't fully implemented dependency inversion also in this library, which is the CWK logger. We have just decoupled the app from this CWK logger. And in fact, what we have done here, and let me briefly go to architecture and show project diagram, is actually that we have inverted this dependency, because as we started the video, app or our application was depending on the CWK logger, and it needed to know a lot of the internals of the library, which is certainly wrong. And that's kind of like the main concept of why we need to invert dependencies, because higher level modules should not depend on lower level modules, but both instead should depend on abstractions. And the idea is that even if we have here a dependency from the lower level module, which is the logger in this case, to the higher level module, this is only a direct project reference and dependency. But if we look closer, the only thing that we actually depend on is this iLogger interface that we defined here in the app, which is our client, the owner of the interface, or the module that will actually use the functionality and that defines what should be actually on that interface. So this is the only dependency that we have. So the definition for the dependency inversion is kind of like achieved, because we depend only on an abstraction and on nothing else. So we don't depend on details from this app class. Now, the second part that I haven't covered in this video and that I have done here is that we had also here some internal dependency from on the logger manager that depended actually on the CWK logger, and it depended also on the log formatters. And what we have done, we have created abstract classes, like for abstract logger formatter and the CWK abstract logger, and we have implemented this, and we have created also a very basic factory that kind of like would provide formatters to our logger manager whenever it would be needed. And by doing this, we have actually also implemented this dependency inversion principle here at this level in our lower level module. Now, the idea is still that you see here that for the abstractions, I have actually created abstract classes. And there is a reason for that. Now, when we create abstractions, from my point of view, there is one thing that we have to be careful about. Now, for instance, if we have here a higher level module and a lower level module, like logger manager was the higher level module, and then the formatters were the lower level modules, and the logger itself, the CWK console logger, it was a lower level module that the higher level module depended on. Now, the idea is that those are actually here in the same library. They are in the same project. And if we think conceptually about them, like the console logger, it's actually, well, it is a CWK abstract logger. So in this case, inheritance works actually just fine. Now, usually there is one principle that I would kindly advise you to actually be careful of. Of course, you can actually, well, not obey to this principle if it makes sense, but usually it tends to be true, and it should be at least a red flag to reconsider. Now, when you define interfaces somewhere, the implementations of those interfaces, it would be best if they are implemented in a different layer. Now, if we want to abstract away something that should be still implemented in the same layer or in the same project, then if we have an inheritance relationship, like an is a relationship, I would totally go for the abstract class, not for the interface. So that's the reason why I have chosen here to actually abstract those lower level modules away by using abstract classes like the abstract logger formatter and the CWK abstract logger. So that's kind of like the setup that we have right now. Now, what we want to achieve here is that right now we have this logger that's actually not working because it's null. And we said during this video that, okay, this should be provided through dependency injection. So let's start and creating our IoC container. And for this, I'll go here and I would add a new project, and I will have this as a class library, and I'll call this IoC. Let me also spell it correctly, container. Okay. Or let me just call it IoC because it's shorter and it's kind of like it's obvious what it should do. So we create this project, and as said, this would be actually a very, very simple one. Okay, of course, I need to add this also to Git, but I will not do this right now. I will add this after the video. So let's change the name of this class and let's call this service factory. Cool. So we have this service factory, and the only thing that we will actually do in this service factory, let's call it also service factory, and it would be static. We make it, or we keep everything very, very simple. So we have this static factory. Now, the only thing that our class will have here is a method public static, and what it will do, it would actually provide an iLogger. So we'll say here that I want an iLogger, and let's call this get logger. So that would be actually very easy. Now, what I would like to do here is, for instance, var console logger equals new, let's say here console logger, or even, yeah, let's have it here console logger. Okay, and then what we want to do is return logger manager. Actually, it would be return new logger manager. So a new instance of this logger manager in which we need to provide the console logger, because that's how the logger manager works. We need to provide a type that's kind of like an abstract logger, CWK abstract logger, and the console logger is one. Cool. So that's what we are doing now. We have some things to consider. We see here a lot of red things. Of course, here we are missing some project references. So let's start at them one by one, and here say reference project CWK logger and import CWK logger targets console logger. Cool. That's exactly what I would like to do. Now for this other one is the import missing reference in file, because it references the same project, and now we should be good to go. Now we have this logger manager, but now this iLogger is actually a public interface in namespace app. Cool. So what we have done here is that Rider automatically added a reference here to our IoC, to our app. And if we check the project references, we see here that we have on projects, we have here a dependency here on this CWK logger. But I guess right now I forgot to actually remove the dependency from here. And actually, that's something that we need to do here because we don't really want to have this dependency on app. Okay, we have this dependency on app because we depend on the iLogger interface. And as you can see, we already have kind of like a certain problem. And let me just show you here the service factory. Actually, everything should work fine. Let's see the problems. No problems. Cool. Now, let me show you what actually the problem is, because remember the setup. We have this app, which is the consumer, which needs some functionality. So we call it the client. And we said that we have to stick to this principle that the client owns and defines the interface. And that's exactly what we do. We have here this client, and well, it defines what the interface is. Now, let me show you what happens if I want to go here and say, for instance, service factory get logger, because that's our class. And let me, for instance, go here on the red light bulb and see, okay, the only options that I have here is create type service factory. But I don't want to create a type. I have it in my IoC project. So what's the problem actually? Now, let me check here. We want here a dependency on the IoC container. Like if we have an IoC container, that's an external stuff, and it's fairly okay that our application would depend on it because it needs it to resolve or to get dependencies injected. In this case, just constructed via a factory. But the problem here is that if we see here in this project, in dependencies, here we don't depend on any project. Now, if we check here these dependencies of the IoC as we did earlier, we see that it actually also depends, it has a transitive dependency to app, because this CWK logger had this direct dependency because it needed the interface. Now, this creates a very, very big problem, because right now what we would need to do is actually go here in this project and we want to add a reference to our IoC. But if we try to do this, we say here that it introduces a circular dependency. And this is not allowed in .NET. So we are not allowed to have circular dependency. So right now we have a very, very big problem, because what happens is that, hey, okay, I want my client to define the interface and own it. But then I have the IoC container that kind of like needs a reference to this interface. And either it gets it directly if we directly reference this, or it gets it in a transitive way through our CWK logger project. The problem is that, well, in this case, I cannot add the dependency to the IoC container in my app. So that's a very big problem. And that's kind of like actually where we came towards, I would say, the only real exception when we don't have to stick, or we actually can stick to this principle that the client owns the interface. So what we are doing here is that, or what we usually do when we are in this type of scenarios where we're creating some kind of like an IoC container and we cannot really implement it because, well, the client defines the interface, and then we would need a circular dependency. So what we usually do in this case is that, okay, we take all the abstractions and we put them in a dedicated abstraction project. So this is the only, well, time or exception, or let's say scenario where you would like to create, or where you would need actually to create a dedicated project for abstractions. And believe me that unfortunately I see that a lot of developers are kind of like, I don't know, creating by default. When they create their project structure, they create an abstraction project. And in 99% of the cases, that project is actually not needed, because if we are using the dependency injection container from ASP.NET Core, we are actually good to go. So we don't need to implement our own IoC container. And kind of like this means that when we create this type of setup where we have something similar like an IoC container, we need to create a single unit of deployment between the IoC container and itself and the abstractions that it actually needs in order to work correctly. So what we'll do in this case to actually solve this problem is add here a new project. And in this project, we'll call IoC abstractions, IoC.abstractions. And in this project, kind of like what we will do here is, let me just make this a little bit smaller. So we have these IoC abstractions, and we have this class 1. We just need to delete that. We don't need it. Edit and delete. We don't need this. And what we'll do here is actually we'll take this logger and we'll move this logger into the abstractions. Cool. And now, of course, this kind of like breaks a lot of things. So the first thing that we would actually need to do here in iLogger is the namespace is not correct anymore. The namespace for the logger is now IoC.abstractions. And of course, we would actually need to cascade this change everywhere. So here is using app, but here for the iLogger, theoretically, if we want to reference project IoC abstractions and import abstractions logger, and okay, right now we have this this logger and we are good to go. Now we don't really need this using app anymore. And then for the service factory, in this case, we can go here at the, so first of all, we can go to all the projects. And here in this case, we will not need a direct reference to the app project anymore. So let me remove this. We don't need this anymore because everybody right now will take the interface from the IoC abstractions project. So we don't need that anymore. And yeah, if we go here to the service factory, we see that using app, that's something not that we would need. And right now, theoretically, if we go here, we should here reference project IoC abstractions, which is cool. And right now our service factory should be good to go. And then the logger manager, kind of like it has the same problem. Like here we had the using for app, and yeah, this app is actually not doing anything anymore. And instead, what we want to do, let me briefly check if we, no, we don't have this dependency. So right now we add the reference to IoC abstractions. And right now we should be good to go with this one. And if we go up one level here, the service factory, theoretically right now we can reference the IoC itself and we get a service factory. So now we should theoretically be good to go. Cool. Let me just check the problems one more time. There are no problems. And yeah, let me try to run this project and see if everything is okay. Or if we have missed some error or not. But I assume it should actually work. So the build was successful, and indeed we see here the logs that we have created using, first of all, the default logger formatter, and then we have this kind of like exception log formatter. Now, if let's check briefly once again the dependency. So here we depend on the IoC abstractions, which is correct. Here we depend on IoC abstractions, and that's also correct. And here actually we have as dependency only, well, actually nothing in the abstractions because it doesn't really depend on anything. So if we go here to tools, architecture in this case, show project diagram, and we see that, okay, this project doesn't really interest us at all. So we see that we have this kind of like the IoC container and the IoC abstractions, and we have this app. So actually we see that app depends on this IoC container. The IoC container depends on the CW keylogger because it needs the classes to actually instantiate objects to provide to the app. And the CW keylogger, it depends only on the IoC abstractions. So right now, by introducing this kind of like dependency or inversion of control container, what we have achieved that previously, if you remember at the beginning of this video, our CW keylogger was depending on app. Now, even if though this dependency was just relying on an interface, which was not wrong, but what we have achieved using this very short or very simple concept of inversion of control container is that we have totally decoupled this app from the CW keylogger, or vice versa, the CW keylogger from the app. And all of our projects, all of our layers kind of like now only depend on the IoC container. And I say they only depend on the IoC container because we have to consider this IoC project and these IoC abstractions a single unit of deployment. So even if they are different projects, they should be always a single unit of deployment and actually go together whenever we do some changes. So they shouldn't go or be handled or versioned separately. They should actually stick together like if they were the same project. But now we see that we have everything that's loosely coupled. The only thing that binds everything together by providing instances when they are needed is the IoC container. So that's actually all. Once again, as a short summary, we should always try to stick to this concept that the interface is owned by the client, which means that we should put the interface actually where the client is, or where, or in the assembly that needs the functionality, or that needs a certain functionality that should be implemented by somebody else. So there is the place where we define the interface. The only exception, or the only exception to this principle, is whenever we want to create something like an IoC container, because we have seen that this would incur or imply that we need a circular dependency, and this is not allowed in .NET. So in that case, what we would need to do is take all those interfaces, all those abstractions, and put them into an abstractions project that logically belongs together with the IoC project. So they are a single unit, they belong together. But this is the only time when we would actually need, or really need, to have or to place interfaces in a dedicated assembly only for them. Whenever you have projects or systems or whatever kind of setup that you have, where you have this type of projects that only contains abstractions, and you don't implement an IoC container in that specific solution, system, project, whatever, then it means that you are probably not doing things 100% according to this dependency inversion principle. And that's actually a decision that's very important, because it might have some architectural or and technical repercussions on the entire project. And yeah, you would also, as an, I don't know, senior engineer or architect, you need to be able to explain to all of the other team members why actually is that you have this dedicated abstractions project, when in fact actually those abstractions are not really needed. And as said, in most of the cases, 99%, I would dare to say, we should just place the interfaces, or they should be owned and placed in the assembly where we have their consumers. So yeah, that would be it. If you enjoyed this video and you would think that also others will find it useful, please feel free to share it. Don't be shy. On your social media, in forums, wherever you see fit, and wherever you think there are people that actually might be interested in taking a look at what we have discussed here. Also, a thumbs up would be highly appreciated, and of course subscribe to this channel if you didn't do this already. It would be totally appreciated. And if you have anything to say, if you just want to add something or whatever goes through your mind, don't be shy and feel free to use the comment section of this video, and I would be more than happy to get the discussion going and have a chat with you there. Once again, thank you very much for watching, and until the next time, I wish you the very best.